All right. Today, the agenda includes 3 items. The first one is going to be presented by Lei about our Istio security testing plan. Second one is a reusable auth-n method definition. Third one is Istio CA key protection using soft HSM. I think they are all very interesting. For the first one, I want to emphasize it. This effort, Istio security testing plan, is what we are going to do for targeting at 1.2 specifically. But of course, it will be last forever, right? The test plan. It's something we need to do for long term. But for 1.2, we are already targeting at improving our tests, improving our code quality, our documents. So yeah, let's start.
Yeah, thanks for the introduction. So I'm Lei. I'm from Google Istio security team. And we have a proposal for Istio security testing, and we want to collect the feedback from the community. And let's go through this proposal.
The purpose of proposing this doc is to get some feedback from the community, and also we would like to get more involvement, like the community. If you can help us to improve the documentation, the tests, everything, that would be also greatly appreciated. This is the main goal for 1.2 release.
Yes. So let's first look at the unit test. So right now, Istio unit tests are spread over the folders in Istio repository and the Istio process repository. Istio process repository has the Istio Envoy sidecar code. And for the unit test, so right now our coverage is about 77%. So we can look at the coverage number by going to this link. So I'm going to click this link to take a quick look. So you see right now it's around 77, and we can also see some detailed statistics here. So like this unit test, they calculate the statistics from different folders. For example, mixer, pilot, package, security package. And the 77 number is from, the security package folder. So back to the planning for the unit test. So first, we want to increase the test coverage for the unit test. So our target certainly is higher than 77%. For example, ideally, we should reach 100% unit test coverage. But right now, we are not at that yet, but that's our target. So when implementing a new feature for Istio security, besides the functional requirement, for example, we should add the unit test to cover the expected behavior of the feature. We also want to add the unit test, for example, for memory access, for example, ASAN test, address sanitizer test, TSAN test, thread sanitizer test, and memory leak test. And if a code that is accessing the network resource, for example, send a TCP packet or access a network point, we also want to add the test that to check this network resource are properly released. For example, a port is released after use. And also we want to ensure this code is production code quality. For example, if there is network disconnection, well, this code can fail gracefully or return some corresponding error code.
Is that falling to the unit test scope, or it's more on the integrated test?
I think some tests, for example, I see some functions like a send message, right? This send message function, right, they are actually using a network port and bind to a port, we want to make sure this like a unit test for this function, for example, send a message to work correctly, and can handle different exceptional cases. And we also want to check invalid inputs, and because we are Istio security, right? So for our code, we should check that we use the library that has the latest security vulnerability patches. For example, when we link to our OpenSSL library, we want to make sure this library is, for example, FIPS certified. And we also want to make sure our code is free from the buffer overflow vulnerability and different vulnerabilities. So we encourage the owners of a new feature to add such a test.
Can I just ask about scope here? When you refer to our code, do you mean like package security, or when you say our code, do you mean Istio as a whole? Like some of these things are specific security tests. Like, do we have updated packages? Are we vulnerable to random input data, which could very easily apply to other components like Pilot or Mixer or things like that?
Yeah, I agree. That's a good point. Actually, a lot of these things for our when we say security code, they actually the security code also in Pilot. For example, the security policy is interpreted by Pilot. So this code will distribute it to different folders, like a Pilot under Pilot folder, under Istio process folder, and under the security package folder. So since this is a security sync-up meeting, so currently in this document, we focus on security test. But I agree this should be applied to the entire Istio community. So we actually have another document on Istio security test that's more general. But here, due to the time limit, we focus on the Istio security. But let's follow up on this because we hope this can be applied to different areas of Istio, not just restricted to security.
Yeah.
Okay. Okay. So we encourage the owners to be responsible for the unit test. So right now, since our coverage is only 77%, we encourage the owners of different security features to look their implementation and find out which unit tests are missing. And for example, can create the GitHub issues, and we can track them, and we can seek help from different community members, or we can find the resource to add to increase the security unit test coverage.
One thing I can point out is the different components, we do have leaders, right?
Yes.
For example, CLDL and CLDL agent, and those and security aspects in Pilot and those stuff. Each of the leaders can figure out what's their coverage. They need to improve, especially which folder, right?
Yes.
And then they can figure out, maybe issue a bug, to issue an issue, open an issue on GitHub to assign that to someone.
Yeah.
Yeah. And then I hope I can expect that there will be a lot of new GitHub issues coming out for fixing those unit tests.
That's a good point.
Yeah.
So next, we proceed to integration test. So in this document, when we say integration test, we use this term interchangeably with end-to-end test to represent the test that goes through multiple components. So we have actually in the Istio repository, we have a new framework to implement the integration test. It is under the test integration. So compared with the old framework, so I'm opening this folder actually. So compared with the previous framework, I think it's called the previous framework is called Tests E2E. This new framework, they offer better features to support the implementation of integration tests. So we encourage the developers to use the new framework. And go back here. So for the integration test coverage, right now, I think it's a similar story as the unit test. I think for our integration test coverage is not not every feature is covered by integration test. So for right now, we organize the integration test based on feature. And when we say feature, we basically mean core user journey, CUJ. So this is a table of the CUJs currently on Istio.io website. So Istio.io website has, let me show you here. So has a task, security task. So this security task constitute the set of our features. Let me open this one. Task, security. So on the left column, we can see things like authentication policy, authorization, authorization for TCP, authorization for groups, and Istio Vault CA, mutual TLS. So different features and different CUJs. So right now, when we organize the integration, we organize based on these CUJs. So we have this table, and the owners, we expect the owners to fill in the, for example, the link to the integration test or the corresponding document to run the integration test. So currently, this table is basically not the details haven't been filled yet. And you have a comment?
Go ahead.
Okay, so for the integration test coverage, we ideally want to reach the 100% integration test. We are not at that stage yet. So Oliver have mentioned for the leaders, like technical leaders of different features, or the owners of the features, we encourage them to look at their implementation and found out the integration tests that are missing, and adding the integration test and the documents.
So yeah, I want to chime in a little bit here. So we will probably start to do this by the leaders of each component, and then we create a series of issues. We will assign them to all the members here, and also if someone from the community wants to pick up some issues to fix, we are very happy to assign to you. You just ping us. And also we may have some issues tagged as help wanted, then you can contribute.
Yeah.
For those integration tests, especially there's one thing that isn't covered in this doc is their documentation. The documentation needs a lot of improvement, and I don't see a lot of work on that in the past. I think we, from the community, I really want people from the community to be able to help as well. For example, there's one thing missing here, like setting up the custom trust domain. That task is still missing. And also for the existing tasks, we may need some improvement.
Yes.
Right?
Yes.
We welcome the community to submit your PRs to Istio, github.istio.io to fix those documentation whenever you see errors there. Okay.
Okay. So next, we proceed to performance test. So, so different from integration test and unit test, performance test, they are more for the performance critical code. So there are components or functions or modules that are performance critical. For example, authentication filter, authorization filter, and the CA pass, so the pass that issue the certificates for workload. These components, they are performance critical. And we actually have Istio tools repo to host this performance test. This performance test, they measure the CPU consumption, they measure the memory overhead, and the latency of the different components. And we encourage the owners of the different component to validate whether their code or their functions or components are performance critical. If so, please add the corresponding performance test under the Istio tools repo. So let me open an example here. So this is the Istio tools repo, and under the perf, this is a performance folder. So we have different tests for the performance. For example, right now we have the test under different load. So we create a different traffic load and measure whether our CA can handle under the large traffic load. We also have tests to measure the CPU consumption and the latency. So we encourage the developers to add their performance test under this folder using examples here. We have, let me open actually an example. So this is an example for the SDS test. So we have each test, we have a README to describe what this test is and how to run this test, and what are the script to run to release the resource after the testing.
What's this qualification, or is this qualification test for the releases, or?
That's a good question. So basically, we have the developers run this test before release Istio release. So this is a qualification test.
Okay.
Yeah.
Right. And those numbers, where do we report them to, or?
Yeah. So there are two ways to run this performance test.
Mm-hmm.
So one way is for the developers, they should run this performance test to make sure their code change doesn't affect the performance. For example, if someone changes a pilot code, and this may be create a large overhead, make the code very slow, or make the memory consumption very high.
Okay.
So the developers should run it. And secondly, the developers that in charge of release the Istio release, create the Istio new Istio releases, they will run it as a qualification test.
I see.
So there are basically two use cases.
So the release engineers we should prepare those performance tests for the release engineers to run them and then give the numbers.
Yeah, give
to
the
customers.
instructions, and we have numbers. I think Amanda has the numbers for this test, the performance test. Okay, so this table is some of the security components that are performance critical, but it's not exhaustive list. This is just a few examples. So we expect the owners of different security features and the technical lead to add the details for the for this performance test table. So here, I think I covered. Okay, so as to the planning for the performance test, so we like I said before, so we expect the owners and the TLs to identify the performance critical components and adding the corresponding GitHub task to add the performance test if such performance tests are missing. Okay.
All right.
So we encourage the community to contribute to the testing, and any help are appreciated. So if there are any feedback, please let us know.
Cool. If there's no questions, we can go to the second one. Reusable authentication method definition. I don't know who proposed this. Spike, are you? No?
I think Dean, but Dean is in the I think is a summit, right. Is a security policy summit.
All right, okay.
So we probably should skip this one.
Let's skip this one, yeah. Go directly to the third one, Istio CA key protection using soft HSM. Yeah, I like this one. Let's discuss it.
Hi, this is, can you hear me?
Yes.
Okay. This is Manjunath here, so I'll be presenting.
Could you introduce yourself a little bit before you start?
Yeah,
I
mean, my name is Manjunath, so I work on the open software generally. So I'm a software engineer at Intel. So currently kind of working on the networking side, and especially in the security and the core network. So I also work on another project called ONAP, which is the operators are trying to automate the network. So I mean, STO is kind of very useful to us, so we want to contribute to STO as well.
Cool.
Yeah, in terms of STO CA private key protection, so an HSM is an hardware security module. They are considered kind of root of trust entities. They generally kind of hides and safeguards and manages digital certificates. Soft HSM is a kind of a software version of that. So it's emulated an hardware security module. So that's it's so for now I'm choosing soft HSM because it's the software is readily available, and we don't have the license issues and different like that. There is no dependency on the hardware module itself. So this is kind of protecting using soft HSM. The solution should work with any other hardware security module as well, so that they come with their own libraries and tools, so which kind of like makes it hardware dependent. So if we can do this with soft HSM, it's the solution should be applicable to any hardware security module as well.
So is that because every hardware security module has the same kind of application programming interface, the PKCS 11?
That's right. Yeah. So they all use PKCS 11, which is standard and kind of defines the platform independent interface to this hardware security modules. They have to go through this PKCS 11 interface, and all the major languages like Go, Java, C, C++, they all provide a way to interact with PKCS 11 interface. So, is there any other questions?
Yeah, but this is a general question. So this HSM interface potentially could also be used on the node agents, right? The CDL agents.
Yes. Yeah.
I think that in order to do that, you can't dig the private key out of the HSM, right? And Envoy will need it to do TLS. So Envoy will have to have some sort of support for this if you want. Or you'll need like handshaking API or something, right?
Right. That's correct. Yes. We don't have that yet.
So for the flow of this, if this is go through the Citadel agent, then the envoy through the SDS request the certificate and reach the Citadel agent, and the Citadel agent use the soft HSM to, so the deployment is on the Citadel or on the Citadel agent.
So this is going to be part of the Citadel. So we are currently focusing on protecting the CA private key itself. So this is going to be the part of STO_CA, the binary. So we'll be making modification to that. So which kind of it creates a bundle and stores the CA private key inside the bundle. So we are, the idea currently is to protect the CA key. So,
I see.
if you want to do it for Envoy, that's a different scope. And there are ways to do it, but the initial focus is kind of for the CA key right now.
Okay, and for the PKCS11 part, so the Citadel agent speak PKCS11 to, or the Citadel itself use the PKCS11 to talk to the soft HSM.
Right. The later.
Yeah. So this is the diagram. So generally, there are tools and utilities, PKCS7 utilities that are available. That can directly talk to the PKCS11 interface, and they will help in like importing the keys, initializing the device, and maybe slicing the device itself. In terms of Go apps and Go stack, it comes with there are two packages right now: the Crypto 11 package and PKCS 11 package. These packages are available on GitHub, and the Go Crypto 11 works in conjunction with Go and provide and implements interfaces like signer, verify, the crypto operations, and which in turn uses PKCS 11 package to talk to PKCS 11 interface, such as soft HSM or any hardware security modules. So the Crypto 11 itself kind of needs the description of the underlying HSM. So it's done through a configuration file or through making a function call. So like it needs like label, pin, and path of the library itself.
Okay, so based on this diagram, actually it doesn't have to be the Citadel, right? Because this PKCS11 library can be on the Citadel agent, and through the calling this PKCS11 utilities or library, it talks to a software HSM or hardware HSM to get, for example, you mentioned the sign and the signature verification. And basically for certificate issuance is mostly sign, right? To sign a CSR.
Yeah. Yes,
But
this is general typical stack. Yeah, it can work for any key. So currently I'm kind of focused on CA key, right? So yeah,
basically I'm trying to understand where is the best place to integrate this PKCS11 into.
Well, in our architecture now, isn't Citadel server the only place that is the CA that's signing the certificates? The agents don't sign certificates, right?
Yeah, the agent doesn't sign the certificate, but
so this has nothing to do with agents then.
But the agent is actually the SDS server, and the agent, the Citadel agent, through linking to this PKCS11 library, it can just request the soft HSM to sign the CSR without going through a Citadel, because the Citadel basically is here is the owner.
Then every Citadel agent will become a CA in your case.
Yeah, and we don't want that. We want a central CA.
It's not the CA per se, it's a CA client, because it's actually talking through the PKCS11 library. It doesn't own the key. It's just through this protocol request the CA to sign something.
Yeah, but with an HSM, the idea is that this is actually tied to the hardware that the thing is actually deployed on, right? So it's not like you could. This is like some generic interface that you can use instead of talking to the Citadel server.
I think this is just a library. It's a it's a standard. The PKCS11.
So PKCS11, PKCS11 allows you to protect private key material, and so this would be you definitely could use this on the node agent. The node agent needs a private key, and it just does operations with the private key. It does not imply that you are a CA in order to use.
Yeah, it's not a. In order to use this PKCS11 library, you don't have to own anything. You just get a handle to the HSM, and then you use the handle to request a signing or signature verification operation.
The point here is HSM, not PKCS11.
But the HSM is deployed somewhere, right? It's either deployed as a.
It's on the same machine.
PKCS11 is usually an ABI, not an API. So there's no like.
Yeah, there's no remote over the network kind of way to do this. This is talking to your local hardware. So while it's true that the node agent, like maybe it needs a private key in order to assert itself to the Citadel server, for the actual signing of the certificates that get distributed out to the envoys, that all happens centrally. And so we're talking about building this into Citadel server so that you can protect that CA private key.
But you actually could use it to protect the private key that is on individual nodes as well.
Sure, but that's not that is true, but that's not the CA, and that's not what this proposal is about. This proposal is about the CA, and therefore is on Citadel server.
That's right.
Sorry, I missed that the scoping part. Never mind.
Yeah, that's fine. I missed that as well. At the beginning.
The thing that I think is worthwhile pointing out here is that even if we wanted to consider use case where HSM is used on agent side for signing related signing operations, handshake API, and those kinds of things, HSM usually has a limited number of keys that they can perform operations with. So, you know, it is certainly not as flexible as what we have today.
Okay, yeah.
Okay.
So in terms of design, basically, yeah, based on these two packages that are available, and they provide the operations that are required. I mean, there are tools, like I said, available to initialize the device and kind of import the key. So, and each HSM will have their own hardware-specific scripts that kind of import the keys into. They initialize the token and create the keys, import the keys into it, both the key as well as the certificate. And it also kind of creates the configuration file that is required by the Crypto11 package. So, and from the application itself, the key can be found.
Hold on, I have a question. So when you see the token, you are mentioning the token used for PKCS11 login interface, or what token you are talking about? The provision of this token.
Yeah, it's basically, they call it the device itself token. So for example, some devices can be divided into slices, and they call it a token. So you can create a multiple tokens and you give it to different applications. So that's the main idea.
So the application here is the Citadel server.
Right. Yeah. So
Okay.
in our case, we will have only one slice that will contain the CA key.
Okay. So how does the Citadel server store this secret? Because the Citadel server needed to be provisioned with this secret and use this secret to log in the HSM. I'm just curious the details.
Yeah, it's coming down. So
okay.
Yeah, basically from the application itself, you can find the key pair by providing the label and the ID. So to the application itself, you pass in the command line arguments. You enable it by using a protected CA key, and give the ID you want to use, which will be used in the script to import it, and the label. Using one of those, you can find the key anyway, right? So the HSM name will be used where it's kind of uses that particular script to kind of import the key. Specifies,
Basically, the provision of the key is through running a script, and a human is needed to be involved.
no, we can run it from Go itself. Go can run a script. So, but the script itself needs to be part of the
But in order to run
image.
this, yeah, but in order to run this script, the script requires an input parameter called token. That's a secret. I'm just saying, I mean, because the idea here is for security. How do we safeguard this secret, or how do we, protect this secret from, because we can't write this secret to the code or to the script itself.
So it's not clear to me whether it is a secret. Like, what does this token represent, and is it actually a secret that needs to be protected?
My understanding is, in order to use the private key in the HSM, the application here, which is the Citadel, need to log in to the HSM, and this token is the login is required by the login. Otherwise, any application can use the private key to sign something.
Yeah, that pin is a secret. So this is where we kind of created the right. So it's required in creating a token, but we don't need it to actually use the key, right? All we need is a label or ID to use the key. So it's I mean, if you want to kind of import any new key into the token, then you need the pin. Otherwise, from the application perspective, you just need the label.
So how would this work in a containerized environment, right? If you're running Citadel in a container and you don't need the pin in order to use the key, does that mean that any other container that happens to land on the same node and has the right software could start pretending, could start signing stuff with that key?
It's the label. I mean, the label kind of is the one which uses. So in Go, it's kind of different. They don't use this, but in Java they kind of use. You need that pin in order to access the key. But with Go, it seems like it works without pin being asked. So, but this is just with the soft HSM. But with real HSM, it could be different and it might be enforced.
Okay, I really expect the real HSM to have some like secret for that specific container the Citadel is running to be able to use the HSM, not other containers. But that one gives me a question: how do you store that secret, right?
So we're not storing this. We're not storing this. This is passed in as an argument. So
right.
I mean, it could be different for different deployments.
Yeah, but who's passing it in?
Yeah.
It's the deployment. I mean,
so does that mean that
some administrator? Yeah.
But I mean, that's just passing the buck, right? In terms of storing it, right? It still needs to be stored somewhere and retrieved and used without exposing it, right?
Yeah, but that's at the deployment level though. So it's kind of comes down to like how do we manage your secrets at deployment level?
At deployment level, the most secure thing that you can use on Kubernetes is using Kubernetes secret. So that means you could store that
Yeah.
in Kubernetes secret.
Kubernetes
But
secret. Yeah.
yeah, but then that is equal to storing the CA signing key in the Kubernetes secret.
Yes. So
Well,
basically,
it's not quite true, right? Like
Go ahead.
even if some attacker is able to expropriate these pins
Yeah.
from Kubernetes, they still need physical access to the hardware. They still need to get their software running on a node that has
On
the
that
HSM.
node, yes, but that node, you cannot guarantee which part is running on that node unless you provision that node to be specifically for this serial. But by default, the
Well, I
scheduler
mean,
can.
you have to pin. I mean, if you
Okay.
do this, if you go down this route of an
Okay.
HSM, you have to pin
All right.
Citadel to a node, right? There's just no other way around it, right?
Right.
Yeah.
Okay.
Yeah. It's like, yeah, there's a dependency in the hardware. Yeah, it has to come up on a particular node which has the HSM. Yeah.
so if the this pin is stored in the Kubernetes secret, then compared with the current store the CA key in the.
They don't have the difference is normal, like malicious users cannot access that node. That node has the private key, and that node is not exposed to malicious users.
The node, you mean the node on which the Citadel reside?
Right.
Okay.
Yeah.
But
So even if you have a pin, you won't be able to extract the key itself.
Right.
So
yeah, you want to be able to extract the key itself, but you still can need to, for your purpose, you can trick the, I mean, you can sign anything, right?
No, you don't have access to that node.
But this is stored in the API server, right? It's stored as a Kubernetes
you have that
secret.
secret. Yes, you have that secret to get that sign.
Yeah.
But it doesn't allow you to deploy any workload on this node.
Yeah, but what I need is to get the secret. I don't need.
How do you get it? You need to go into that node, right? Because that node has the HSM.
Let's say if I'm a user, I can run kubectl get a secret and then -o YAML, then I get the secret. Get the pin.
Then what?
Then I use that pin to log into your HSM.
No, you cannot. You cannot go into that node. That's the point.
What about if I'm admin and I deploy a pod on your node?
Yeah, if you're admin, you can deploy a pod on that machine. Then you can deploy. You can change anything. You can change Citadel as well.
Yeah. So basically, this is the same as getting the private key from the secret. Not exactly same.
No, it's definitely not the same.
It's
right?
not the same. Here, the private key itself will not be exposed because of the HSM, but you still can sign anything.
Yeah, you cannot protect admin to do anything, to do like any malicious things. Admins can access that node, then everything is done. But you can protect people other than admin.
This is essentially the weak link of this this system.
We can discuss that offline. Yeah.
okay, so so basically the key cert bundle already have a crypto private key, so we don't need any data structure changes that are required. So it's existing code should be existing data structure should work. So in terms of so this will be kind of useful in protecting plugged as well as external CAs. So in either case, the CA key can be protected. Same thing with the multi-cluster. So we will have intermediate certificates, intermediate keys and certificates. So that's also can be protected. Yeah, so make sure the existing software works, and alongside, making the make this an option so that existing options and supported code works. Yeah, in terms of identified changes, I mean, it's basically kind of reference to the key instead of the actual key. So there is some interface changes required. And there is a verification code that needs to be modified because we don't have the actual key anymore. Soft HSM related tools like soft HSM util PKCS11 tools, they needs to be installed, and unit test cases, and also for the integration test, the Citadel test container has to be created, and the vendor dependencies like crypto 11 PKCS 11, that needs to be um, resolved as well. So I mean, those are the changes I have, and yeah, that's all. That's the overall idea I have.
So I'd like to just say that overall, I think that this functionality is valuable for a CA, right? And that being said, there's a lot of different ways that this can happen depending on the different types of hardwares. There's also other kinds of backings that give similar levels of protection, like cloud-based HSMs and other things that won't be PKCS 11.
Yeah.
And those are I think are also valid use cases, and quite frankly less expensive most of the time.
Yeah, I actually want to add a perspective here is, so right now Istio support Vault CA, and Vault CA is actually not using the PKCS 11, but it doesn't require the PIN. It just needs the Kubernetes service account. It has the Kubernetes service account authentication method. So here, Vault will never expose the private key. So it seems we should, actually get a comparison in terms of which one is, in terms of the security of these two different approach. One is Vault, another is this soft HSM. I somehow from here, this pin is giving me the security concerns.
Yeah, so I mean, it's an operator choice, right? So yeah, I mean, I agree that there are multiple solutions, but the reality is people use different ways of getting the security. So this is we're not saying this is the only one, but it's an choice for the operator. So I mean, yeah, Vault CA could be used, but if somebody already has a deployment and they want to use the existing CA keys, right? So this is one options they can use.
To clarify, right, if you're using Vault CA, then you are bypassing the Citadel component, right? And
that's true. The Citadel agent will send the Kubernetes service account together with the CSR to Vault, and the Vault authenticate and authorize based on the Kubernetes service account.
Right. So this proposal is the proposal to directly extend Citadel, a component which is not even in the Vault option. So while Vault is certainly an option for CA, and I suspect that they probably in the commercial have some sort of HSM.
And another difference here is the Vault can be just a remote CA server. So a lot of corporations, they just provide their Vault endpoint. They don't actually deploy their CA or their private key into the cluster. They just provide an endpoint, and Istio just integrate with the Citadel agent to be specific. Integrate with that remote endpoint.
Yeah. So there are different use cases.
Yeah.
And we are not talking about that use case here. We're talking about different use case. Yeah.
Right. Like if as a user I want to say I would like to have hardware backing for my private key management, is the recommendation then don't use Citadel?
If you are a user, are you willing to deploy your private key into the Citadel?
Well, maybe only if it has hardware backing. Some companies have policies.
Yeah, only if you know it's secure for sure, or you probably just want to deploy your CA at your own environment and just expose an interface. I'm not sure.
I mean, actually, people do that because of the cost reasons. So I've seen, there are deployments as well. They run their own CA. And it's mainly because of the cost reasons. So yeah, it's I mean, not everyone, but some of the deployments do have it.
I mean, I think like the core question here is, do we want to continue iterating on Citadel CA, and do we want it to be flexible, right? If we're saying that you have extra requirements as a user, use a different CA backing, then that's fine. But if we want people to continue using Citadel server, then I think, you know, we need to have some sort of story, right?
Yeah, exactly. That's also my point. I totally agree with you. So we are not saying like we want to go get rid of Citadel, right? We want to be able to provide two approaches according to different scenarios. If the users have an environment that offers this PKI, we can easily hook up with them. We offer this flexibility. And also, if for those users that they can deploy this cluster with their trusted infrastructure, for example, with HSM, they can easily use Citadel, which offers better manageability. Yeah.
So just to kind of like bring this, so that's, you know, on that kind of note, to bring this kind of back to what I was saying before, is that there are multiple use cases for, you know, quote hardware backed keys, and I think PKCS based HSM is one of them. And just to give like point of reference, the way that we've handled this in Spire is like a crypto.signer extensible interface. So if somebody has their own HSM hardware or some custom foo, or they want to plug it into AWS Cloud HSM, then there is like a small targeted bit of logic required to do this, and you don't have to touch core in order to extend for, like, you know, maybe vendor specific pieces.
And is that an internal kind of API, like the use case is to recompile Spire with your new code sort of inserted in that, or is this like a kind of remote interface, like a gRPC call or whatever?
Yeah, it's a little bit of both. You can statically link it if you want to, or you can do an out of process plugin, which is fully node local.
So, I mean, I think it may be desirable for us to define those kind of extensible interfaces, and this could be a sort of first plugin to use that kind of extensible interface. But I also see the value in having just kind of out of the box PKCS 11 support, so that like if you want to integrate with your HSM, yeah, you have to layer in the actual libraries that talk to your HSM and stuff like that, but you don't have to recompile Citadel, for example. You just put in a bit of config and say, okay, well, you're going to use this signing plugin, and it's going to talk to PKCS 11, and here's all the arguments that you need, right? Which Manjunath has started to collect in this document.
Yeah, I agree. I think that there's value in out of the box PKCS 11 support. The part that I'm trying to, sorry, man. All right, sorry about that. The part that I was trying to say is that, jeez. It's unstoppable. There it is. The part that I was trying to say is that I think that there are like some small variations that are vendor specific, and maybe someone can jump in here and correct me if that's not the case. But I think that there are some, like smart card, for instance, I think has like a fairly standardized and well understood PKCS 11 semantics, but vendor specific, there are like some vendor specific nuances to HSMs. At least that's you know what my understanding. And kind of littering those vendor specific stuffs is the bit that I'm talking about. Like we're talking right now about core calling out and running a shell script. To accomplish that, right?
Yeah, I don't think that we should get in the business of doing that kind of thing, right? Like initializing the HSM and getting your key in and stuff like that. That can be done in init containers or whatever else you want to do. as an operator. I don't think that needs to enter into Citadel's kind of core at all. And so I don't like the interface where it's like, oh, here's the name of a shell script that you should execute. But having that API to be able to talk to PKCS11 and defining what the information you need in order to do that, I think is a good direction here.
Yes, I agree.
Agreed.
Yeah. Thanks. Thank you, Manjunath. I think we can move on this direction to see more feedback and work together. And even what do you propose, like general interface for like Cloud HSM is also interesting. It would be great if you can provide some reference here in the doc. That would be great. Yes.
Yeah, no problem.
Thank you. We may iterate more on this doc in the future. Okay.
Okay. Thank you.
Thank you, guys.
Bye.
Bye-bye.
Bye.
Thank you.